print bone.
Thank you. Thank you for the invitation. Arno just asked, what are we going to print? And what applications do we need? So here's the answer. Very simple. We print bone. And in fact, everybody know bone, right? Everybody here know how to print. So this is going to be the shortest introduction at all today. Any questions? No? Okay. No. In fact, let me walk you through and tell you a bit about Particle3D, what we do, and where we are. So that you don't sit all of you just looking like this, saying, not going to happen in decades. It will. Okay. So what's the pain point here? What's the problem? Why do we want to print bones? Why don't we just do as we do today? Because the surgery of today is not optimal. What we see is patients today get harvested bone fragments from their own body. So you need to have a surgery on your bone or your leg, your arm, somewhere to get in the fragments to maybe repair something in your jaw, your face, anywhere. So this is, of course, costly, 2 operations, and high risk, and longer recovery. The other thing you do today is you do 3D print, in fact, but you do it in foreign materials to the body, so it's not natural. You do it in titanium, in plastic, and other kind of materials. This is not optimal because it can be rejected. The body doesn't want any foreign material inside. It's causing often bleeding and also infections. So what we see today is that we have high complication rates and resurgery rates, often because it's poorly fitting and it's not degradable and it's not porous. These are the 3 main problems of today. And it also has the problem that we don't see very good functional outcome and very good aesthetic outcome of these operations of today. What do we bring? We're a new company bringing in the P3D bone. It's a 3D printed, patient fitted, and natural bone implant based on the patient's own CT scan. So this is, in fact, what we need. It's like just doing your own bone again. And the 3D printing brings in exactly patient fit. And this enables, of course, faster ingrowth. And it's porous, so what we see is that it becomes real living bone. Why does it do that? Because we do it in calcium phosphate. It's degradable bioink that degrades over the years, so your own bone tissue will grow into this scaffold and become real bone again. And it's only 1 operation, okay? Another thing is, these implants are made from powder with a fatty acids, so you could bring in other powders. What about putting in some antibiotic, some chemotherapy, maybe some growth factors? There are lots of possibilities in the future to grow in this. So it's a platform that can grow with partners in the future. Okay? So this is individualized, porous, degradable. So this is what we can bring in. Okay? Why does it matter? Yeah, for patients, of course, better aesthetic outcome, better functional outcome, faster recovery, fewer complications. So we are improving outcome and reducing complications. 2, for the professionals, shorter surgeries. We have competitive advantage, and most of all, reduced cost and higher productivity. So this is streamlining the workflow at the hospitals and the clinics, so, and most of all, reducing costs. Good. Who are we? Small Danish medtech company founded on proprietary technology, spin out from the University of Southern Denmark. We are working to make bone implants both accurate, effective, and safe. We've been funded the first time in 2018. We have received several awards and grants for developing this new technology. Latest yesterday at the AM Venture Day, we received a fine grant, so very grateful and honored for that. We are today 5 employees, and yeah, I'm the new CEO, trying to get this into market within a couple of years. So wish us luck. Good. What's the market? How many do we need to make of these? Yeah, today bone grafting is made 2 million. There's around 2 million implants surgery every year. Okay. Furthermore, we see cosmetic surgical procedures, around 500,000 procedures worldwide each year. Okay, so looking at the total bone implant market, we see approximately $3.6 million market, billion-dollar market, of course, and with an annual growth rate around 5.5. So it's huge, it's growing. Furthermore, if we look at the bone implants with some additives, this is, of course, going to expand the market. Our initial target market will be the US. There are several reasons for that. It's a huge market. Right now, it might be easier to get into the market on regulatory ways because we see the new IVD rules in Europe. So we are going for the US market. We expect to make a 510K. So this is the market access model we're heading for. Good. Looking at the sales model, quite easy, but will take some challenge. We take the CT scan, and the surgeon will have the CT scan, do the model himself or herself, and design through the software we are providing. So in fact, he's the designer. He's the designer of this implant, so he knows better the patient and how to do it. Send it to a P3D hub, and here it will be printed, it will be sterilized, and it will be freighted back to the surgeon. And of course, then we see the surgery. Seems easy, but of course, we have some way to go to get this in place. Other market players? Yeah, there are other market players. We have the titanium implants we talked about before. We have the bone harvesting. We see today somebody making, kind of models to cutting guides. So these are also in market. We see some calcium phosphate blocks that you manually have to fit to the patient during surgery. And we see some 3D printed bone implants, but not in a natural material, so they're not degradable. This is what we see today, and this is, of course, P3D bone, all green. Surprise! Have we tried anything with this? Yes, we have. We have 5 animal studies now, 3 mice studies, 1 pilot pig trial, and then the latest is a second pig trial with 8 pigs. Very good results. We see strength, mechanical strength. We see they are free from contaminants. We see that they integrate with the neighboring bone. And we see that it's supporting rapid formation with into new bone. So this is all seen in the latest study. Of course, we need a bit more studying. We need it to get it into human at some point. But firstly, we need to make a GLP trial nearly like the one we've done, to make sure that all results can be used during the FDA application process. Okay? Looking at the technology, we have a worldwide patent pending. It's a 3D printing technology, and it can go into nearly any industry. So it's just a buying any powder with a fatty acid. We print it directly from a CAD file, okay? So it's loaded into a syringe, heated to its melting point, and then we just extrude it. And from there, it re-solidifies. This is more or less the picture of it. It's a worldwide patent. We just got information last week that they intend to grant. So positively European. And again, the platform, because it can be used with nearly any kind of powder, we go into so many different industries. We don't, but we can sell it for a license. So this is the idea of it. And very shortly, our trefoil strategy is to go with the bone. The Particle3D bone is our main course. This is what we go for. We have some possibilities with partners to go with additives. We have some R&D products, which is more or less just scaffolds that we put into any kind of, any well or anything you need to make any research on, then you can have bone implants in that. And then, of course, everything's based on the technology and the IP. Next point, I just need some funding. So if anybody wants to speak with us, please give us a call or come around. Of course, you can always come ask questions or whatever. So thank you very much. Sorry.
Thank you, Karen. Thanks very much indeed.
Yeah.
Thank you very much indeed. Does anybody, before we break for coffee, I mean, I don't, if that's not innovation in the additive manufacturing space, I don't know what is. And funding, right here, I know it's right there. So is anybody, quickly before we break, has anybody got any questions? Yes, sir. Incidentally, I really like the fact that you trademarked We Print Bone. Yeah, sorry.
That'll come in handy. I mean, firstly, I think you've probably observed there's a big market for printing toes. But this might just be a very clumsy audience. My question's on supply chain. So I'm from Stratasys, and we have a very big install base with our printers in the medical industry. And they're used for surgical models, training models. But we know that the supply chain, if you can call it that, in the medical industry, predominantly in North America, but in Europe as well, it's not like a supply chain for the typical industries for additive, aero, consumer, heavy industry, automotive. Hospitals don't want to print stuff, or at least they're very ill-equipped to do so. So university hospitals might be okay with it. My question is, in a short way, is who's going to do the 3D printing if it's not the hospital, and how does that workflow look?
I think, in fact, that the printing is not really the problem. You know, we have experts in printing nearly any kind of thing today. So it's more to qualify this hub for printing exactly what we want them to. And of course, this is going to be in a sterilized way, and you know, so it's not easy, but I don't think that is where we're going to see the major problem today. And I think we really see that a lot of things are happening in this area right now. You know, we meet a lot of people saying we can do that and we can do that and we can help you out with that. So yeah, 14 days ago we went to Munich, and a lot of big companies say, okay, we are heading there and there and there. So I agree with Arno that I think applications and what we are going to use this technology for is the real issue. Where does it matter? So I think we'll get there. Of course, it's a challenge.
Excellent. Thanks very much, Thea. I really appreciate it. I'm afraid we're out of time.
Sorry.
Right.